Since the dawn of civilization, humanity has gazed upwards, enchanted by the enigmatic allure of the cosmos. Ancient civilizations built monuments aligned with the stars, and philosophers pondered the universe's vast complexities. This celestial curiosity has been a constant throughout human history, evolving from rudimentary star maps to sophisticated space probes. The 20th century marked a pivotal turn in this astronomical journey. Technology advanced, allowing us not just to observe the stars, but to reach for them. The launching of Sputnik 1 in 1957 ignited a new era of exploration, marking the beginning of humanity's physical journey into space. As we delve into the specifics of this journey, from the first satellite to plans for Mars colonization, it's clear that our celestial curiosity remains undiminished, propelling us towards an ever-expanding horizon. The launch of Sputnik 1 by the Soviet Union on October 4, 1957, marked the beginning of the space age. As the first artificial Earth satellite, Sputnik sent shockwaves around the world, proving that spaceflight was achievable and igniting a technological race between superpowers. Following closely on the heels of Sputnik, Yuri Gagarin's historic orbit around the Earth on April 12, 1961 in Vostok 1 catapulted human spaceflight from fantasy to reality. Gagarin's famous words, "Poyakali, let's go," echoed around the world, inspiring awe and admiration. The space race fostered a competitive yet paradoxically collaborative atmosphere among nations, driving technological advancements at an unprecedented rate. It also sparked a global interest in science education, with governments investing heavily in research and development. As we moved into the 1960s, the space race accelerated, leading to more ambitious missions focused on landing humans on the moon, a dream that would soon become a reality. The Apollo program, initiated by NASA in the early 1960s, was driven by President John F. Kennedy's bold declaration to land a man on the moon and return him safely to Earth before the decade's end. Apollo 11 successfully made its lunar landing on July 20, 1969. Neil Armstrong's first steps were a giant leap for mankind. This moment united people across the world in a shared triumph. The technological innovations developed during the Apollo era had far-reaching impacts. Advances in telecommunications and computer technology have since become part of everyday life. The Space Shuttle program, initiated by NASA in 1981, marked a new chapter in space exploration. Unlike its predecessors, the Space Shuttle was designed as a partially reusable vehicle, reducing the cost of access to space. This innovation allowed for more frequent missions, including satellite deployment, scientific experiments, and interplanetary probes. It enabled the construction of the International Space Station and the launching of the Hubble Space Telescope. However, the Challenger disaster in 1986 and the Columbia disaster in 2003 were somber reminders of the risks. The program continued until 2011, completing 135 missions and shaping modern space travel. The International Space Station, a product of international collaboration, stands as a testament to what humanity can achieve when it works together. Initiated in 1998, the ISS has been continuously inhabited since November 2000, serving as a microgravity and space environment research laboratory. Scientists from multiple countries conduct experiments in biology, human biology, physics, astronomy, and other fields, contributing invaluable data that could not be obtained on Earth. The ISS has been pivotal in fostering international cooperation. It is a joint project involving NASA, Roscosmos, JAXA, ESA, and CSA, demonstrating that space exploration can bridge even the widest geopolitical divides. Living and working in space for extended periods has provided insights into the long-term effects of space travel on the human body, essential for future missions to Mars and beyond. As we look to the future, the ISS continues to be a beacon of international unity and scientific progress, influencing future cooperative efforts in space exploration. The entrance of private enterprises into the space sector has dramatically transformed the landscape of space exploration. Companies like SpaceX, founded by Elon Musk in 2002, have introduced new technologies and revitalized interest in space travel with their innovative and cost-effective approaches. SpaceX's development of the Falcon rockets and the Dragon spacecraft has made resupply missions to the ISS more frequent and economically viable. These milestones have not only proven that private companies can operate in space effectively, but have also encouraged competition and innovation within the aerospace industry. The rise of private space enterprises has also facilitated public-private partnerships, with NASA and other national space agencies contracting companies like SpaceX and Boeing for cargo and crew transport services. This model has allowed for more efficient use of resources and accelerated the pace of space exploration development. As we continue into the 21st century, the role of private companies in space exploration is expected to expand, potentially including lunar bases, Mars colonies, and even space tourism. The exploration of Mars represents the next significant chapter in humanity's quest to explore the cosmos. NASA's Perseverance rover, which landed on Mars in February 2021, is one of the most advanced machines ever sent to another planet. Its mission, to search for signs of past life and collect samples of rock and regolith, broken rock and soil for possible return to Earth, highlights our ongoing fascination with the red planet. Various space agencies and private companies are planning manned missions within the next decades. The goal is not just to visit Mars, but to establish a sustainable presence, paving the way for future colonization. The challenges of Mars exploration are immense, from the technical difficulties of landing and returning to the psychological and physiological impacts on astronauts during long-duration missions. However, the potential scientific returns, understanding whether life existed on Mars, the planet's geology, and its climate history, are profound. Mars is not merely a destination, but a gateway to the broader universe, a stepping stone to the stars. As we venture further into the 21st century, space exploration expands beyond the Moon and Mars to envision missions to asteroids and the outer planets. Concepts like space elevators and warp drives, once science fiction, are now studied seriously. These technologies could revolutionize space travel, reducing costs and increasing efficiency. Mining asteroids could address resource scarcity, providing materials for Earth and space construction. Discovering life or habitable environments on moons of Jupiter and Saturn excites scientists and the public. Missions like Europa Clipper and Dragonfly aim to explore these worlds, seeking signs of life. The advancement of technology is critical in shaping the future of space exploration. Innovations in propulsion, materials science, robotics, and AI extend our reach into the cosmos. Ion thrusters and nuclear propulsion promise faster travel and extensive exploration. Robotics and AI transform missions, handling complex tasks and making autonomous decisions. Lighter, stronger materials withstand space's harsh conditions. Life support advances ensure astronauts can live and work in space longer. Each innovation brings us closer to answering questions about our place in the universe. The impact of space exploration extends far beyond the technological and scientific achievements it yields. The images of Earth from space, such as the iconic blue marble and pale blue dot, have fostered a sense of global unity and environmental consciousness, illustrating the fragility and isolation of our planet in the vast expanse of space. Space exploration has inspired a multitude of works in literature, film, and art, reflecting humanity's deep-seated curiosity and ambivalence about the cosmos. It challenges us to think about our place in the universe, our potential destiny among the stars, and the ethical considerations of colonizing other planets. By working together in space, we learn how to transcend terrestrial disputes and collaborate on common goals, reflecting a microcosm of how global cooperation could potentially evolve. The cultural impact of space exploration also includes educational influences, inspiring new generations to pursue careers in science, technology, engineering, and mathematics (STEM). As we reflect on the journey of space exploration from Sputnik to the potential future colonies on Mars and beyond, it's clear that this endeavor is one of humanity's most profound narratives. Space exploration not only pushes the boundaries of our scientific and technological capabilities, but also expands the limits of our imagination and spirit. The future of space exploration holds limitless possibilities. It promises not just the expansion of human presence into the cosmos, but also the deepening of our understanding of life and the universe. As we stand on the precipice of new discoveries, the journey of exploration continues to inspire, challenge, and evoke awe. The story of space exploration is our story, a testament to our potential and a beacon of hope for the future. As we continue to explore the great expanse, we not only discover the cosmos, we also discover more about ourselves.